Okay, let's go for some Lamis theorem. Already you know. So this I'll use to define the equilibrium of objects here. So first word equilibrium, I'll bring it. A body is at rest if a body is at rest under action of forces is said to be in equilibrium. Okay, fine. So the one definition is what? Equilibrium, we define it. So what is the basic necessity condition? The net force on the system should be zero, or summation of fx should be zero, summation of y should be zero, summation of z should be zero. The forces that are acting along x, along y, along z, the resultant of all forces must be zero. We can discuss the equilibrium of along one direction in a plane or in 3 dimensions. We'll explore one by one. So let's take the, so I'll already we have discussed this. So the body I kept on a ground. Is it in equilibrium? Yes. So we'll balance the weight mg, then the normal contact. So what is the state of it? It's at rest. So under action of forces n and mg is at rest. So what is the equation you can write? N minus mg equal to 0. It's in equilibrium. That's what you can see here. No, equilibrium due to which forces? Any forces, we are not bothered about the nature of forces here. Any force under action of any type of forces, the body can be in, the system can be in equilibrium. This is one basic condition. Now let's discuss some problems. I'll just gather some problems, some good problems. Based on Lamis theorem, first we'll work out few, then we'll go for the other things. Okay, first we'll start with this. Today it's like a just introduction. From tomorrow, we can work out many different numericals. Okay, these are the rope 1, this is string 1, this is string 2. The system is in equilibrium. You have to find out the tension in the strings. There's a block suspended. So there's a joint. It is some. So we have to find out the tension in string 1 and 2. Okay, now what is the state of block? It's in equilibrium, no? So we'll balance here tension T3 will balance mg. So here tension T3 will act here. Then come for this one. So here tension T2. So this is 30 degrees.
$60, sir.
Yeah, I'll come. This will be 60, no? And call this as T1. This tension you call T2. So you can take Lamis theorem or equate forces along X, along Y. So we'll balance what is T3 equal to from the diagram. T3 should be equal to mg. T3 minus mg, so T3 equal to mg. Then T1 cos 60 minus T3 equals 0, or T1 by 2 equal to T3, or T1 equal to 2 mg. Then T2 minus T1 sine 60 equal to 0. T2, T1 value is how much? 2 mg. Sine 60 root 3 by 2. So T2 equal to mg root 3. So like this, or Lami's theorem, you can apply it. So can you remember Lami's theorem? You can also do this by Lami's theorem. So what is Lami's theorem? T3 by sine of 90 plus 60 should be equal to T2 by sine of 90 plus 30 equal to T1 by sine 90. It's left to you. Either equate forces along x, along y, solve it, or take a Lami's theorem. But what is the condition with the Lami's theorem? Only when there are forces are there, 3 forces. More than 3 forces, you can't apply Lami's theorem. Am I right? So therefore, I do prefer equating forces along x, along y, so that any number we can manage, no? Any number of forces we can manage here.